I just want to do a quick video about the Pythagorean theorem. Um, it's a very simple thing to understand, and it means that if you're discussing observations with interested people who are fairly new to this and are trying to understand what they're seeing, but don't realise that they shouldn't be seeing it. And when you give them when you just use the 8 inches per mile squared sort of mantra, that will to some people mean nothing, and then to others they will ask, where did you get that from? And you'll say it's Pythagorean theorem, and they might want to understand how that calculation is performed, because they're just not convinced that it's right. So if you can show them, and it's very simple, it means you don't have to rely on the calculator. And a lot of these calculators have a lot of variables added in there which are not helpful and they're not needed. So basically the Pythagorean theorem is just a squared plus b squared equals c squared. So you know two sides, and you can work out what the third side of that triangle is by knowing the other two sides. So the one at the bottom here, I've got 5 times, so one side is 5, one side is 4, we're trying to work out what the other side is, so I've labelled C. So 5 times 5 is 25, 4 times 4, 16, add them both together you get 41, and then basically find the square root, and 6.4. So then if you apply this to an observation, you know the point you're standing at, you observe something in the distance that you've got a feeling shouldn't be there. You look on Google Earth, you look at the distance, plot it out. So you've got that side. You know the distance in miles to the observation that you shouldn't be seeing, because it should be hiding behind a curve. The other side, you know, because that's the radius of the Earth from the center of the from the center of the ball Earth. The radius is 3,958 miles, so that one side will never change. You get your observation distance, and then you can work out what the length is of the other side of the triangle, and then all you have to do is take away the radius of the Earth from that figure, and that gives you the drop height without any other bollocks in there. So if we watch this Logs to Ailsa Rock observation that Dell did, is a good example. I'm sure he won't mind us using it.
Point, which is in Largs. So you can see here where we are.
Yeah.
Now, there is the rock. Now, the important thing to notice here is this reflection here, people. Okay? Hugely significant, hugely important. You're seeing the reflection of the rock because the water is continuing all the way, but because of this band, the optical effect that we don't have an exacting science for here, because our vision is limited and the sky is being reflected on the water, right? Same as the rock is being reflected on the water. So we can see up to this point, which would be our horizon, and then beyond that we're having serious problems. I mean, you can see other objects here in this band, right? But the important thing is the contours of the rock, and the reflection on the bottom of it. Now that rock is only 1,100 feet in height, so the calculation for that distance was 800 feet, 800 odd feet. So really you should be seeing about that much. The obstruction should be away up here, right? And that is beyond. So you're not looking beyond a curve where the rock is being refracted up into your visual range, horizontal, perfect for you, and displaying a reflection. Okay, solids display reflections. Mirages and imaginary invisible stuffs do not. So the huge significant aspect to that is the reflection that you're seeing on the water that's leading all the way up to it. All right. So that's the first observation from Largs to Ailsa Rock.
Right now, I think we must be a bit even more than that.
Okay, so we saw the observation. Observation was from Logs Bay at the RNLI, the Lifeboat Institute station or office or whatever it was, looking out, and you could see Ailsa Rock, which is this big old lump. Looks exactly like you observed, and the distance on Google Earth was 39 miles. So, observation distance, 39 miles, not in dispute. So we've got one side. The other side, the triangle, is the radius of the assumed spherical Earth, that is the claim, and we're proving that it's not the case just through simple observations. Obviously, it's totally unnecessary when you know that water can be nothing other than flat and level bodies of water, and you're in air pressure. But all you're playing the observation, so you're helping people. And if you can show how you're working this out, and it's very straightforward, it'll be helpful. So observation distance is 39. The radius of the Earth, which is the other side, 3,958. So with these two bits of data, we can work out the length of this side, and then we can remove the radius of the Earth from it, and then we're left with the so-called drop. So the radius of Earth, 3,958 squared, is 15,665,764. And you add the observation distance, 39 miles, which squared gives you 1,521. Add those together, that gives you 15,667,285. It's irrelevant. You do it on a calculator, quick, easy. Right. To find the square root of that number, calculator, square root button, and that gives you 3,958. Well, immediately you see that that's the radius of the Earth. Take that off. So now we're left with 0.1921 miles, which, when you convert that to feet, gives you over 1,000 feet. We know from Wikipedia that Ailsa Rock is, where does it say this? Did say this, or Dell did say it. Here we go. Highest elevation, 1,109 foot. When so 1,109 foot. Fuck's sake. 1,014 foot of it should be hidden. So you should just be seeing a teeny little teeny weeny bit. And you weren't. You were seeing the whole thing and you were seeing its reflection in the water. So it's very simple, and I think it's a good thing to have a grip on, be familiar with, do it a couple of times, and it'll come as second instinct. You'll never have to rely on 8 inches per mile squared, or if you do, you'll be able to show immediately how that's done. Especially if you're out somewhere doing an observation and you're drawing people in and talking to them, just quickly draw it out. You could just have a few of these printed out without this data on, and just fill in. Look, this is what this is. This distance is a Pythagorean theorem. Yeah, hopefully it's helpful. See ya.